Okay, in lesson 8, we're going to start relating a fraction of a set to repeated addition and the fraction of multiplication. And we're also going to be looking at the algebraic aspect of how to work. Okay, in question 1, as you can see in the example, it's saying we have 2/3 plus 2/3 plus 2/3 plus 2/3. Now that's actually repeated addition, and we know when we're adding like fractions, so denominator stays the same, and adding 2 4 times the same as doing 4 times 2. So our answer ends up being 8/3. So in our example, now we know our denominator would be 3, and it'd be 5 plus 5 plus 5 is 3 times 5, which equals 15/3. Our next one, 13/5 plus 13/5 becomes 13 times 2 over 5. And our last one, and I'm going to write it down below here, we know our denominator is 4, and we have 9 times 3, which equals 27/4. Okay, using our example up top, as you can see, we know this would end up being 3 times 16, because repeated addition, over 4. Now I'm going to decode this to make it easier, and I'm seeing the 4 down below, so I'm going to go 4 times 4 is 16, or 4, which 3 times 4 is 12, 12 times 4 is 48 over 4, and I know 4, we're going to 48 12 times. Now let's see, if I go back to our original, which is 3 times 16 over 4, then we decoded that to 3 times 4 times 4 over 4. We're multiplying and dividing by 4, so we can take those out, and 3 times 4 equals 12. So we didn't end up having to convert from a fraction to a whole number since we did our eliminations. On the next one, we'd end up 4 times 12 over 3, which equals 4 times, and I'm going to decode, since it's 3 on bottom, 3 times 4 for 12 over 3. And when I multiplied this, I know 4 times 12 would have been 48/3. Then I'd have to divide this to figure it out. I know 48 divided by 3 would be 16. So the answer here would be 16. But you notice I had to go to a standard algorithm to solve it. Let's see if we go back to here where we had 4 times 3 times 4 over 3. We took out our two common factors, and the answer is 16. And we did not have to go to the standard algorithm. On C, we have 40 times 11 over 10. And I'm going to decode that now. So 40, I know I can go 4 times 10 times 11 over 10. And I know 4 times 10 is 40, 40 times, or 10 times 11 is 110, times 4 would have been 440 over 10, and 440 divided by 10 would give me 44. Now let's see how this looks when we decode it. 40 times 11 over 10, and we went 4 times 10 times 11 over 10. We take out the 10s, and we got 4 times 11 is 44. Our next one, 7 times 36 over 6. So I'm going to use 6 in my decoding. 7 times 6 times 6 over 6. And now, when I multiply this back out, if I had to do my multiplication, I'd end up with 36 times 7, be 42, be 21, 25, 252. So we have 252 divided by 6. Now I'm going to have to come back over here and do a standard algorithm. 252 divided by 6, which would go in that 4 times 24, 12. So we'd end up with 42 would have been our answer. Now, let's come back to here. 7 times 36 over 6 equals 7 times 6 times 6 over 6. We're taking out our common. 7 times 6 is 42. We didn't have to go back to any of them standard algorithms. Our last problem on this sheet, and we end up with 24 times 5 over 8. And I'm going to decode 24 since I know it's a factor of 8, which would be 3 times 8 times 5 over 8. And 5 times 8 would be 40. 40 times 3 would be 120 over 8, which equals, and I'd have to go 120 divided by 8, be 1 time. This 40 would be 5, so we end up with 15. But notice I had to go back standard algorithm again. So now we're going to go 24 times 5 over 8, which equals 3 times 8 times 5 over 8. Take out the 8s. 3 times 5 equals 50. Okay, on F, 18 times 5/12. So this is going to equal 18 times 5 over 12. Okay. Now if you notice on this one, it doesn't, I don't have any multiples of 12 on top, but I can break this down because I can know that 18 and 12 both have 6 as a common factor. So I'm going to go 6 times 3 for 18 times 5. And then down here, I can go 6 times 2. When I take my 6's out, I ended up with 15 seconds. And I know 2 will go into 15 7 times, and 2 times 7 is 14, so there'll be 1 left over. So it ends up being 7.5. On G, we end up with 10 times 21 over 9. Now, once again, there's no multiple of 9 on top, but I know that 3 is a multiple of 9 and 21. So I can go 10 times 7 times 3 for 21, and 3 times 3. I take out my 3's, and I'm ended up with 70 over 3. So 70 over 3, if I do my long division on that one, 3 will go into 7 2 times. Gives us 6. 1, bring the 0 down. 3 will go into 10 3 times, be 9. 1 left over, and 1/3. So that would equal 23 1/3. Now, okay, now let's try to see how we can put this into practical application. And this is through conversions. Now, if you see up there, it says 1/3 of a minute equals blank seconds. Well, I know 1/3 would be 20 seconds. Well, let's prove it. So here we end up with 1 times 60 over 3. Well, I know 1 times anything is going to give me the same, so this is actually just 60 over 3. And I know if I break this down to decode it, I can have 3 times 20, which would give me 60, and 3. So take those out, and I know that equals 20. Now, the next one, 4/5 of 60, or 4/5 of an hour, equals how many minutes? So, 4/5 of an hour, so 4 times 60 over 5. And I know 60 is a multiple of 5, so I'm going to go 4 times 5. And for 60, it's going to be 12 over 5. Take out our common ones, and I know 4 times 12 is 48. So 4/5 of an hour will be 48 minutes. They've already done C for us, but just in case they haven't, because sometimes my book's different, you can see what they did. They did 7 times 1,000 here over 10. And I'm going to decode it for you here, because 7 times 1,000 over 10. Decoding that is 7 times 10 times 100 over 10. Take out the 10, so we got 7 times 100, which is 700. So that'd be 700 grams. Our last one, we're going to have 3 times 100 over 5. And we're looking for multiples of 5, so it's going to be 20. We got 3 times 20 times 5, which equals 100, over 5. Take out the 5s, and we got